morning again. Welcome to the Hidden Gems of Distributed Tracing. Happy to be in front of you and in such a large number. Also last year we were quite a few, but this year it's all of us, as it should be at JFOL. So a little bit about myself. I'm Anna. I'm originally from Romania, but living here in the Netherlands. These are my two social handlers at the moment. I mean, you probably know about what happened with Twitter. So now I'm also on Mastodon, and you can find me there. Probably I need to remove one N from that. But yeah, that's my handler also on Mastodon. I'm a Java Champion alumni, also and a certified architect, currently working as a developer advocate. But in principle, I'm passionate about solving scenarios that are a bit more complex, involving Java, Java frameworks, and of course, Kubernetes. I pretty much love all of them. Hence, the scenarios today will involve all of them. And let's start by thinking about why we need distributed tracing. But first of all, I want to ask you a question. If you can please raise your hand if you have used the distributed tracing so far, you know the concept or you've heard about it, like please. Okay, so we have a very knowledgeable audience, great. So in case I'm mistaken of something, please correct me. I had only 1 coffee and a half, and usually I need 2. So I'll blame the half that I didn't have if I say something not okay. So why do we need distributed tracing? I mean, we kind of seen that we are evolving from this vintage approach of monoliths, where we knew where our requests were going because it was just one big ball, and typically was connected to one persistent store, and we could have see where our request was very, very easy. But we went with a modern approach, right? With more applications, with multiple persistent stores, and well, in that case, things became a little bit more complex in regards tracing what's going on with our transactions to know what didn't go that well and where didn't go that well. So the story about distributed tracing and why we need it most of the time happens with once upon a time something unexpected occurred. But if it just happens one time, most of the time we don't care. Even the tools, if they record it, they will not alarm you that something unexpected occurred. Like, okay, happened one time. It doesn't matter. Now, the thing is that the tools do record, let's say, a disturbance in the flow of requests. Let's say that this is the best case scenario. You are really watching everything. You get some logs, you get some metrics, but you're not, alarmed that something is wrong. And you shouldn't be. It happens once. Who cares? Maybe it doesn't happen again. It was just a small thing. But next time or next times, well, when this happens, then this becomes a pattern. And you get more logs, you get more metrics. And typically these metrics, they have an impact on service level objectives. So when those metrics are actually going to impact what you promised in terms of achievement to your customer, that's when you're becoming worried and you want to fix this as soon as possible. And distributed tracing is there to help you to solve an issue in disguise, to get more information about what's going on with your requests, to trace your requests. Logs are helpful too, but also minimize the impact that you're having when this issue occurs on your SLOs. So, distributed tracing to the rescue in these cases where you thought that nothing bad happened, but then when they start to happen multiple times, you're like, oh my God, I need to fix this. Or the entire team is like, we need to fix this. So distributing tracing is there to offer us answers about a few things, like which services were involved in these abnormal transactions. To know, first of all, who were the culprits, and to just look at them specifically, not look in the entire system, which might be a ton of services. Then, what were the versions of those services that were traversed by the requests? Because when the situation occurred, maybe you have some versions in place, but you worked on some more, you did more deployments, and now there are different versions, right? So you just need to trace which combination of those versions of services triggered that abnormal situation. And of course, if there were any exceptions recorded, and this is very important, to record the exceptional situations, record the exceptions that happen with your system in order to trace a little bit better what's going on there. Now, how tracing has evolved and why we needed tracing, this is just a small timeline about tracing. So from my point of view, everything started with Xtrace in 2007. when, let's say, microservices were not our primary goal in making systems nowadays. But X-trace appeared because people saw that requests are traversing a lot of networks, and they needed a way to trace where the transactions are going across networks. So that was the first one. Then Zipkin came along in 2012, and then people started to think that they need something like a standard to look into distributed tracing. So open tracing came in 2015. Now, open tracing was great, but was looking only into distributed tracing. The part with metrics, like correlation with the metrics, was not coming out of the box. And when you know very well, like it's good to know where the transaction traveled, but you also have to correlate that with the metrics and with the logs, right? Because just knowing where the transaction was without having more information is not entirely helping you to solve the issue. So, because metrics were needed, open census came up in 2016. And after open census, well, 2017, Jagger, which is pretty much aligned with open tracing specification. But what people realized is that, okay, in implementations, folks were going either with open tracing or with open census. I mean, tools that were aligning to either of those. And if you want to migrate from one tool that was more aligned to open tracing to open census, there was some more work involved. So how to do that much more nicely and swiftly? You need something that unites both of them. So that's what Open Telemetry is from 2019, is the standard that unites both of them, that provides a lot of SDKs, that provides tools, APIs, and how to do things about working with tools that align either to open tracing, open census, and just not having the trouble of migrations and all that down the road. In the talk of today, we're going to look at Jagger only from open tracing point of view, but also at Jagger with open telemetry configuration. So we'll see the differences between both. Now, going back to real life, or kind of real life in this small screen, in context tracking of a transaction from endpoint to endpoint, that's pretty much what an example of distributing tracing looks like. So pretty much a request is starting from at some point. Then, while it traverses a lot of contexts, like across microservices, you add more things to it. So let's just say it starts with the green microservice, then it travels to the blue one. More informations from spans, from the activity that happens with that request, are being added to your existing transaction. Attributes can be added as well by default from the system and the framework that you're using, or your own, if you want to record your own attributes to know your own things and add those things to your request. And then it goes, let's say, to the yellow, where maybe to the yellow it gets an exception, and that would be great to have a recorded exception, like when the exceptional situation happened, like the not so nice, to catch it and record it and to inspect it later on. It would be great also to have an alarm from the tool that says to you, like, hey, I caught this. So this is like, in a nutshell, a bit about the distributed tracing across 3 microservices. But let's go back a little bit again to open telemetry. We saw that, but we also want to collect data. So we realized that open telemetry is good for us because it unites the 2 standards, it unites the tools, the implementation helps us a lot. But how does it do that? First of all, we have the specification. We have different SDK implementations for different languages, for Java, Go, and many more. So regardless in which language you're programming, you're covered. There's an API for developers, for us. And of course, you collect data with the Open Telemetry Line Protocol, OTLP. You're going to see OTLP in the configurations a lot. And this is great because it's having conventions that are vendor agnostic. So it doesn't say use tool X, and then you have to modify those conventions because you move to another tool. You realize, well, this doesn't work for me. I need to move to this new tool. OK, we need to rework all this. Well, that's great from specification point of view. Now, from real life point of view, the collector is there to help us. The collector is a proxy that has 3 parts. The receivers, where the data from our applications is being pushed or pulled. And not only our applications, it can also be from our infrastructure. Processors are the ones that are handling the data that is received. And of course, the exporters are those that are further getting the data, receive data, and they do all their work too. And today I'm going to give you the example of receivers and how the processor is being populated, but also which exporter I used. So this is a small guide to navigate within the traces galaxy from my point of view. Now, first of all, you should keep the OpenTelemetry provider configuration separate from your instrumentation calls. You should start with auto instrumentation by default. That's how I started, by the way, because you should start with the defaults and add your needs down the road. Then you should optimize the tracing strategy with OpenTelemetry in different ways, and there are two ways of using the processor. Either the simple span processor, which pretty much its name is saying, like it's simple processing of the spans, just getting them, not doing much with them, just passing data, processing data. And batch span processor, where you can process your spans in chunks. And in today examples, use the batch span. Now, we get all this data, we get this tracing data, which can be a lot at some point. But this data needs to be stored somewhere. And typically when we're using clouds, we have some storage. If we are tracing everything and we're storing everything, besides performance overhead of tracing everything, we also get to the part where we are storing a lot of data, not necessarily all the time useful. Okay, it's good to have a history. But do we want to know everything? When everything went well, it's good that it went well. But that's why we have metrics, to let us know that things went well. Why do we need to keep also the traces? So how much tracing data is enough? Now, looking in our demo context of today, in which you're going to be involved as well, we're going to have two microservices. We're going to have the hobby, which is kind of a front-end microservice, which is done with Helidon SE. And, of course, there's the backend, so-called backend activity, which is done with Quarkus. Now, the Helidon app is using just the open tracing implementation, I would say, because it's just using Jaeger. So I'm just exporting my traces to Jaeger. The backend is using OpenTelemetry. It's using Jaeger and Prometheus. So the traces are got with Jaeger in both cases. But the countdown of the span matrix is done in Prometheus. So that's the exporter. The receiver is Jaeger, the exporter is Prometheus. And of course, the processor is being configured in certain ways, and I'm going to explain why in the examples. Now I need your help. And I'm going to give you 3 minutes. Okay, 5 minutes. And just don't be scared if things are dying down the road. I'm going to explain why. Do not judge the UI skills or how smart the application is. It's how backend developer, well, actually, a developer with a lot of experience in the backend side programs, front ends. Exactly. Hey, I have even better UIs. And I can tell you a story about my UI skills after the session. I'm not recorded. But yeah, have fun. Oh, I should also go to this. And cannot scan this.
Do you need to be on Wi-Fi?
Yeah, because it's online. It's available. And not necessarily on Wi-Fi, but I think if your data is good, you should be fine. My data is not that great. And it takes a while to load, but I need your requests. And I hope it works.
It does, but it takes a while to load.
It takes a while to load, yes. That's why I said 5 minutes, because let's say 3 minutes for the app to load, and the other 2 minutes maybe you can play with it. let me get another phone with another. Yes, internet on two phones, but it's working better on another one. Let me go to the browser. Oh yeah, great internet. And I'm on the cable. It's fine. The thing is that I also need the real-time debugger to do all this. Okay, the site cannot be reached, great. Okay, loading. Get pause. Okay, kubectl. I'm just checking how my things are being logged. Yes, my applications were restarted a couple of times, at least the front-end ones, because there are some exceptions, which is fine. I mean, the application behaved regularly. But I just need data. Okay. Can you stop for a bit? One sec. kubectl logs. Okay. I also have an activity, so it should be fine. Okay, that's a lot of errors. Good. I mean, errors are good too. I mean, that's the point of the exercise. Let's hope we have some data. If not, I have some data from a week ago when I ran the same demo. And hopefully, yeah, the app was going to be fine back. So, if you can stop a bit, okay, data, thank God. So the idea is that the app indeed in itself is not perfect. It was done like that for a purpose, the two apps. The front end is good, the back end is The story is, if you're looking at this, you get some information. And of course, your responses are obtained from balanced backend. And because you don't know which response is actually yours, I can trick you as an implementer and say, like, yeah, it worked. You got it later, but it worked. But the thing is, like, how to trace when things are not going that great. Because you can see here that from time to time, the workers are like 2, 1, or 3. This means that the application restarts, it's not feeling great. So we need to understand why it didn't feel that great, what triggered that unexpected thing. So let's go to debugger for this one. The first thing that we do, go here and see error equals true, right? We got a lot of errors. That's nice, especially on the activity side. So it seems that this one triggered an error, and there's a 504 from time to time coming from the activity. I think there also were great things happening in the last hour, not just all the time error equals true. But yeah, we also had bad situations. So there's at least one, let me go here. There's at least one 200 response from the backend. So the backend from time to time has issues. Does the front end have issues? Let's check. Yeah, the front end has issues too, like issues everywhere. How do we work with these kind of situations from tracing point of view? How do we know where things didn't go that great? Would be great like we can debug those. So like if we're capturing all the traces that we're having all the spans, again, we get to too much information. We just need only these informations when things are not going that great maybe. It's good that things are going great. We don't need to trace that the transactions went great necessarily. We trust our system. But what do we do in these situations? I mean, we can go in this part, in the hobby, we get some logs, we get some tags, it's 500, it's quite good. But if we need to debug further, It would be great if we can add our own things to debugging, but also those things do not count against our SLO. So exclude those traces from our service level objectives to our numbers that matter to the client. And how do we do that? One way that I can suggest you to do that, use your own custom headers, your own custom HTTP headers, to add your own things on debugging for your applications. So for example, and you have this in the README of the document. For the front end, I can add my own trace debug ID set to local and post my send request similarly as you did in the app. Now this one makes a request, okay, it gets an exception, that's great. But the story is that this part is being added to my request, and I can exclude those spans that have this attribute set further from my entire spans that matter to SLOs, or actually identify those things and help me in debugging and just, put them in a bucket and not just keep them all together with the others. So let me go here, say trace debug ID, set to local, find traces, and this is my trace from 1 minute ago with my own tag, the one where there should be with my own span, actually, sorry. I added a new span. So from the front-end side, I'm adding my own span to my implementation. If you're wondering how I did this, on the Helidon side, I just added a custom filter, and I can show you in a moment. I just added a custom filter for a rule, like for any type of request, add this custom filter, work with headers. And if my debug header, which is trace debug ID, is present, make this new span and attach it to the current context. So pretty much add a new context to add a new span to the existing context with more values. I mean, this thing with the local is just for example, but you can add your own things there and get more information or get more stuff like hello, I get here thing in your code. You can just attach it further, and that's it. And then serve the request normally. Now, this is one for the Helidon part. But for the Quarkus part, I implemented a little bit different, because Quarkus, in my implementation, works with REST-easy. It's great, so I just implemented my own filter, which is called trace request filter. And again, I'm getting the config property, and also in Helidon, I'm just establishing it as a property. I can name it whatever, not just trace debug ID. That's just a name. You can name it whatever. And again, in this case, what I'm doing, I'm getting the filter from the request, and I'm attaching to the current context. So I'm not creating any more a span. I'm just creating an attribute to my request. I'm actually being more economical with my spans and my entire thing. So I'm just putting my own needed attribute. Let's just do that for my backend as well. Clear. Okay. Just for an endpoint, it's just to trace it. So this one worked. And here, just go for activity and find a trace. Also, my Jaeger is configured to get the traces from time to time. Come on. Activity. Must be a few seconds ago. Okay, a few seconds ago, activity, yeah. Timeout span, and the tags, my trace debug ID, that one that I shared earlier. I know, it was not a string, it was just an array of strings for the values. So it records this again in Quarkus side as well. Why is this important? Because you can put your own things, and again, you're just not influencing your own metrics, the one that you're exporting to your customer. Next, it would be great to know how your application performed with those traces, right? So if you're just using Jaeger and you're just going out with open tracing, you need to find a way to align those metrics, your application metrics, to your traces, make a correspondence. But the good thing is, when you're using OpenTelemetry, you can configure, the exporter to be Prometheus and export the span metrics to that. So in this case, and let me show you a little bit, the config map. It was pretty easy. I just said, okay, you process the spans in batch, but the metrics, you export them to Prometheus. So it was easy like that and simple like that in this configuration. So I get my span metrics in the Prometheus part. And you can see here all my pipelines and my configurations set up from the processor side to the Prometheus side all over. And by the way, I'll share the code at the end so you can try it on your own too. Bless you. Now, those being said, let's look a little bit in Prometheus and what happened in Prometheus. It's good to know how many 504s you had, right? And in Prometheus, I need to start Prometheus, actually port forward Prometheus. So port forward, deploy Prometheus. 1990, internet, and hoping that I get something here. Okay, so if I'm just pasting my, my query, my PromQL query for just seeing how were the requests with status 504 in the last 5 minutes, and execute this, I get a number on the endpoints that were not behaving that great and how the system behaved overall. You can also get it as a graph, and you can see a peak and when the peak was of activities and so on the back end, what was the influence of that. So you can see how the server behaved in the errors, and you can trace, okay, it was the activity microservice, but it was the endpoint that was /activity, or the endpoint that was /activity/type, and then you get the parameter type of the activity there. So you can correlate what didn't go that well in a specific amount of time with the traces that you caught in that time and see what's not going that well. And actually look more into what's going on bad and just isolate the problem for that specific time. Moreover, if you're having caches and you want to know how those behave, I can make a small request with hey and just hit some requests for load just for that purpose. So if I just say 20 users, that's minus n, meaning, 20 requests minus n for 10 concurrent users to my backend, I get, of course, 20 responses and some information about how my system behaved and how was the latency distribution. But that's just a tool telling me stuff. Now, if I want to see how the cache behaved, because I'm caching some requests on my backend, I can again use PromQL to understand that and how the results were happening and how many times the cache was hit and how that behaved in the last minute, for example. So just pasted this one here and execute it. And yeah, not 1 hour, but less, make it more relevant. So yeah, we can see how the cache behaved and how was the overall influence over the hits over there. So how many times did I get it from the cache? How many times I refreshed my information that I obtained from the cache? That's pretty much the connection between the tools, but let's discuss a little bit further on how debugging was working. So this is just some of what I showed you. So on the Helidon side, because, by the way, this is just for Helidon SE because there are two parts of Helidon. There's the SE part, which is reactive side of Helidon, and there's the MP part, which is the microprofile side of Helidon that pretty much is resembling with the Quarkus implementation. So for Helidon, I just added some rules in my routing for the endpoint, any endpoint, just go through that filter, process my custom header. Then I adjusted the OTLP processor to use the batch span matrix thing. So please remember that, use the span matrix, because I'm going to show you another configuration in a bit. And then I just curled, or just having your help, I just used to get more requests from you. So that was it. Then on the Quarkus side, of course, I had my container request filter. Again, the same thing, the processor. Then I put the batch, and then I'm just curling. And of course, I use some sampling strategies. These are my sampling strategies for my microservices. And just to explain it, because I use the batch, but for Jaeger, the tool itself, I prefer to go with different strategies. So for activity, I'm using the probabilistic one. So 8 out of 10 requests, I want to get the traces of those. I want to get the span of those 8 out of 10 requests. That's what 0.8 means. For hobby, I want to use rate limiting. So this means 5 requests per second. I want to get them. I want to get that information. The rest, I don't care if I get more requests per second. And for other microservices that will be in my system, I'm just going with the default strategy, which is constant get all. I don't have any other, and it doesn't matter. The constant sampler can work in this case. That was the first part of configuring. But there's another way on how to reduce the amount of data or the amount of traces that you're getting, but still get the important thing from your systems. You can have policies within your OpenTelemetry collector configuration. So you can make your own policies and just customize even more. Now, pay attention in this case. You can use the batch spam processor and batch spam metrics, but you will be confused about the results that you get in terms of metrics and how the spams are being processed further. So that's why I said, in this case, just go with the simple processing and just go with the policies. So in terms of these policies that you put in the OpenTelemetry configuration, you have 3 options. You have the latency sampling policy, and of course, like the name says, based on latency, you get your requests. By the way, one thing to know about the policies, these will collect your traces at the end of the request. So they will be analyzed at the end of the request if they're, sampleable, ready to be collected as a sample. While in the other case, you're just getting the request because Jaeger just needs 8 out of 10 requests or 5 requests per second. It doesn't matter. You want to collect those traces. You don't care if it's either in the beginning or the end. This one is analyzing at the end what's going on and decides and takes a decision on collect them or not. So the first one is on latency. The second one is based on status code. So you get a status code error. You want to collect only the errors. You can do that. Then you can combine them. Now that's a little bit more complex. So the composite policies, you can combine these type of latency, status code, based on your string of an alarm or something like this. You can combine them. You can order them. You can rate allocate them in importancy and based on that policy. And it's even much more interesting to do that and even trim more about what you're collecting from your requests. Again, ways to avoid oversampling. If you're wondering where can you play with all this, in the repo, there's a special folder called Kubernetes. There's something called OpenTelemetry config map. And in the README, by the way, I instruct you what to comment and what not to comment. And you have the tail sampling commented because Jaeger is configured in a certain way. But if you just want to use the tail sampling, you know what to do. Just comment this and use the tail sampling to see what's going on. And in the backend code, you'll see that there's an alarm and a value for it, and that's going to be triggered and being collected only when that is triggered. So just give it a try when I'm going to share the repo and see what's going on there. Furthermore, you have on how much time the decision should wait, 10 seconds after, not collect immediately. The number of traces, 100, and of course, I just gave a rough number of expected number of new traces per second to 10. Those being said, just to summarize, the ways to avoid oversampling is by using the debug requests, using the special HTTP header. Using that, you're avoiding oversampling and just getting too many samples. Secondly, you should use sampling strategy per your application profile. In dev, you can sample everything, but in production, you shouldn't sample everything. You just need only the necessary things that give you information about how your system is performing. And thirdly, tail-based sampling is great, and when you are just juggling with it in OpenTelemetry, can get you even to more fine-tuned information about your system without collecting everything. Those being said, this is where you find the code. By the way, there are 2 branches there. You can give a try to both branches. Code works in both cases. And yeah, you can write the code there. If you think that something can be improved or it's something that you would like to add, I'm welcoming suggestions, issues, and feedback always. But I hope it helps you. And by the way, you have a configuration of Jaeger, Prometheus, and OpenTelemetry collector, but that's not production mode, just to warn you. That's something you can do in dev, because I tailored that to work only with a few resources. So please don't think that that's production ready. It's just something for you to play with. And if you're not a fan of Kubernetes, there's also a Docker Compose file that you can spin up, and you get the same thing. So play also with that one. I give you a few options so that you don't okay, maybe I don't like Kubernetes and just want to use Docker thingy. So have fun with this. And of course, now I'm waiting for your feedback and your questions. Thanks. No questions? Oh, was everything so clear? Any question? Okay, there's a question.
At my work, we use a tool called Honeycomb, which is a commercial tool which does things like it. To what of your whole stack would that be comparable?
Honeycomb for tracing.
Yeah.
I didn't use it, so the question, if I can phrase it like this, it's about a tool called Honeycomb, and where does it align? I would say because it's about tracing, it's probably a version, an alternative to Jagger, and could be the receiver in this case, and the one that you're then further processing information to a tool like Prometheus. There are more tools like Prometheus. I think there's one from Datadog. There are pretty much a lot of, of registries available to collect metrics nowadays and options. I just use Prometheus because it's kind of widely spread and everybody's using a specific stack of Jagger, Prometheus, and Grafana when it comes to tracing and observing what's going on with your system. But I would say that it fits on the receiver side and if it's for tracing, of course, the receiver side. Okay, another question? Yes.
Do you have experience with the distributed tracing across like an event-based system? So let's say you have multiple teams that send messages by the PubSub or whatever. Yeah, do you have any examples of experience with like how to
Example. I got the same.
I guess like our use case, so we're trying to figure out like how long it takes, let's say, an event to propagate from one end of the system to the other.
Okay, so your question is about tracing how long a request it took for a request to propagate in an event-driven architecture.
Like, one system sends a message, does processing, generates a new message, sends it down the road. Yeah. So
I personally don't have experience with such a system, and I wish I would remember the answer that one of my former colleagues gave in the same talk that I did in Barcelona. But I can point you to the same talk, and the question was recorded there because he explained it, because he's the expert on event-driven stuff. And he explained it on how the things can be collected, but it's not impossible to be done as well, also for event-driven architectures. But I'll give you answer that one. Thank you. Or I can point you to where it should be, because I remember that, and I should have remembered the answer. But it's because I don't have experience, so I would rather not point you do it like this.
I guess it's not really common.
Event-driven architectures, I would say, I don't know all the implementations in the world. Like say, okay, everybody does event-driven, or the percentage of the market that does. But I know that's on the rise because it answers to a lot of needs nowadays.
Yeah.
I'll remember to give you the link. There's another question, yeah?
Yeah, so what about going one step further and also tracing where if there's like an error on the user side as well? Is it possible to trace it from like a user's action back to what the user receives on the as well?
Okay, so the question is trace what the user got in terms of error, and to connect, okay, my system is not perfect because you don't know if you're the unlucky user who didn't get the wrong response. But pretty much the users, when they see that the system doesn't behave pretty well, either in the best case scenario, they call support or they raise a bug and not raise a bug. They just say it didn't work for me to finish this, and I got this, and they give you a print screen. That's the best user ever. But most of them abandon the situation. So in the past, we used to see these troubled situations based on abandonment in certain points, but we had analytics in place that were inspecting in the web where the people abandoned things down the road. Maybe it was bad user experience, that can be as well. But we also looked into what our systems were doing, because maybe it was not just the bad user experience and people didn't like the color of a button. They pretty much something happened with what they were doing, and they just said, I'm not going to spend time here and see this loading page or some not so nice behavior that doesn't get them to what they wanted. So I would say analytics can help you, having analytics on your client side, and can get you information of where people abandoned things. and correlate that with what you have from your metrics. I mean, that's one good way to correlate things. Others, I mean, if the user tells you that something went bad, but it depends again on the users. I mean, I'm thinking about my family and my father. I think they probably wouldn't have say like, oh, it didn't work for me. They would just, okay, I'm going to another place and buy this or do this in another place. Yeah. Good question, by the way. Thanks. Yeah.
How do you choose your sampling strategy for a service? What are the criteria to choose the strategy for a service?
Okay, so the question was, what are the criteria to choose the sampling strategy for a service? I would say based on your business logic and how you want to capture the specific of your business. So for example, I didn't show this in the code today, but you will see in the Quarkus code, for example, that the exceptions, when the exceptions in Java are being thrown and caught, those are recorded. Because I want to know when the system, even though that I caught that exception and I'm handling that exception on my backend and I have a handler for that, I want to know when that happened, and I want to catch that in my sampling. That's in the second sampling, the tail sampling one with the policy. But I also want to get some metrics based on that, so you can get some metrics based on that. Typically, you start with the simple way, like just Jagger, for example, and go with the sampling strategies of Jagger, and people are going first with the all and dev, like get everything. And then they realize, okay, but my system is doing really great. And only in these small amount of cases, it doesn't do that well. So it depends on like, okay, if my system goes really, really well, and maybe the probabilistic one is the simple, then maybe probabilistic is not enough, and rate sampling is an answer. Like I know how many requests per second are going to come in my system, and I can just tailor to get this amount of spans based on the amount of requests that come per second in the system. So it's pretty much based on how you feel for that specific microservice that you should sample. And there's another question. Oh, sorry. Yeah. Yeah. Yeah.
One, was that hard? Does it work out of the box? Or did it require a lot of rewrites? And two, what about things like specific ingress controllers which require a lot of tweaking before they work well with your...
Yeah. Yes. So the question is like, how hard is to adopt OpenTelemetry and actually connect that to the tools? Is not, I would say, from my point of view, medium difficulty, and it actually depends on tools. Jagger and Prometheus are like widely known in terms of configuration. But in case that your tool is like having a smaller adoption, it can be a little bit more difficult, and you have to really read the specification of OpenTelemetry to know how to configure it. But in this case, was a little bit easier to configure them. And if you know how the tools are connected before OpenTelemetry and how you were like arranging them, you just need to think about how the processor is going to handle things between the two, and how you're going to do the things there. I didn't try with other tools, but I'm open to suggestions if they're not belonging to any vendor. But in this case, it was not that bad. And regarding code, like coding, so OpenTelemetry is not just aligning these two specifications in theory. It also does it in the SDKs and with the APIs. So pretty much what you were having before in spans and especially in the Java side, most of the packages were the span specification and everything, and attributes were happening, but they're preceded by .openTracing, right? Now it's .openTelemetry. And there are ways to keep your former code that was like OpenTracing aligned with something called shims in OpenTelemetry. So they pretty much figured out on how to migrate your existing things without like rewriting everything and relearning everything, because they wanted to keep what was before in OpenTracing so that you don't like end up redoing everything and making a new tracing thing. And yeah. So it's, from migration point of view, it's not that problematic. And the framework teams, they really work on, let's just say, not showing that to you and making it that easier for you so you don't feel the difference when you are migrating to adopting open telemetry, that you're not like, oh my God, I have to rewrite this part again. And yeah, that's more time spent on that. But yeah, from frameworks point of view, the frameworks are the ones that are taking care to like not show to you those things. But also the specification helps you a lot. Yeah.
More or less familiar with like tracing, spans, and all this kind of stuff. But the policies, where do they come in, and where can you read more about it? Because that's the part where you decide what's interesting, I guess. Or the framework.
Yes. So the policies, there are two parts. There's a policy at Jaeger level. So you can find the sampling strategies at Jaeger. There's one. And if you're speaking about the policies exactly, that's the open telemetry configuration. So the open telemetry configuration, the collector's configuration. You deploy the collector. For example, if you're using Docker Compose, you're defining these also in YAML. But if you're using Kubernetes, I configured these in a config map because it made sense for me to be in config map. They're not having anything secret. They're just having some endpoints, and that's it. If you're thinking about where do you put the sampling, the sampling goes at processor's level in this OTLP, in the open telemetry configuration, right? So the processor's level. Yes, you can read the documentation. Is great. But you can also read this, and you might understand it a little better. And which level in the YAML you should put the configuration. So it's the processor level that has the tail sampling or the processing as a span, processing of spans in batch or simple. So this can be batch or simple for the span metrics. Yes? The policies within the processor? Yes. Yes, so you set them at processor level. Yeah. When you first decide how much time you want to collect them, because as I said, those are collected at the end of your request. That's when you take the decision. Then you put the policies and you just specify them as an array. You can put one or more. By the way, what happens is that the deployed collector knows to read from this config map and just gets them, knows them, how to interpret them and understand them. And yeah, in this case, I'm just collecting both status codes, the error or OK, which is the error and OK from the spans, the success on that. But there's also like the string policy. This is my own policy based on an alarm. So in my Quarkus code, let me see if I can find the lovely part. Okay, so I have a place where I catch an exception. I set the attribute alarm with the value unexpected, say something wrong happened, which is good to know. And of course, I record the exception. That's a good thing to do as well. But if I just want to get this information and get the metrics of how this behave on the policy side, that's how I got this. Get the string attribute that I called alarm, with the values unexpected. It can be more values that I set there for that specific case. And I'm just catching that situation. Maybe I don't want to catch all the time all the exceptions in the world. They don't necessarily mean a lot to me. But in this case, I just wanted to be alarmed and catch that specific span all the time. But based only on that, not using any other type of sampling on the Jaeger side. So just leaving a Jaeger simply as that. Yes. Yes, the collector. So yes, the collector itself knows about this. You just have to specify the policies. It's like you don't have to again be bothering yourself with the deployment. The deployment knows about this. You just have to write them in nice JSON and get them from there. Any other questions? Oh, the end. Sorry. Thank you, but we can talk afterwards more.